Hello, algebra students. Mr. Lawrence here, and we're going to try something different. Going to see if I have a little instrumental music going while I record this video. You can let me know if it was a distraction or if it's okay. And I don't even know if you can hear it, to tell you the truth. I'm assuming you can because this microphone's pretty sensitive. Anyway, let's get on with it. I promised you that we would do some exponential graphing, right? And so here's my equation. Y equals 3 to the power of negative x minus 1. This is a situation, remember here, I think we're going to get an asymptote of y equals negative 1. You remember that? Y equals negative 1 is going to be the asymptote. I'm not going to put it in yet, but watch what's going to happen. All right, I'm going to pick some values here for x. I think maybe I'm going to put a 0 in. And when I get 3 to the 0 power, I get 1. 1 minus 1 is 0. So that's going to go through the origin right there. There we go. All right. And then I'm going to put 1 in for x. And I'm going to get 3 to the negative first. Well, you should know that 3 to the negative first is 1/3. 1/3 minus 1 is negative 2/3. Right? So I've got a negative 2/3 there. And let's see here, 1, negative 2/3, right about there. And then when I put 2 in, I'm going to get 3 to the negative second, which of course is 1/9. I'm going to take away 1, and that's going to be negative 8/9, right? You guys were getting pretty good at this before we got interrupted by the AOAA. And I'm pretty convinced that my asymptote is going to be at y equals negative 1 now. If I would put 3 in, I'll bet you, I'm not going to do it, but you can go ahead. I'm going to get negative 26/27. I'm pretty sure that's what's going to happen. So I'm going to go ahead and put my asymptote in. I'll do it in green. It's not easy being green. So negative 1, y equals negative 1 would be a horizontal line right there. Okay, now, what's going to happen when I go to the left of 0? Well, if I put negative 1 in here, I'm going to get 3 to the negative first, or 3 to the negative first, right? Which is going to be a 3. I'm going to get 3 to the negative of negative 1, which is 3, and 3 minus 1 is 2. So negative 1 is going to go up to 2 right there. Okay, and when I put negative 2 in, I'm going to get 9, and 9 minus 1 is 8. And so I'll be up there. And so my curve is going to look something like this, my exponential graph. Right? Remember that the negative on the exponent causes a reflection across the y-axis. Okay? It'll never touch that asymptote. It'll get very, very close to it, but never quite get there. All right, very good. So let's go down to this one here. Oops. And I've got this equation, y equals negative 2 to the power x plus 4. And let's plug 0 in. I guess my asymptote, I'm guessing y equals 4. Okay, let's see what happens. I put 0 in, I get 2 to the 0 is 1. It'll be negative 1 plus 4 is 3. So 0, 1, 2, 3. There we go. Okay. I put 1 in, I get 2 to the first, it would be 2, make it negative, plus 4, which would be 2. Right? Yeah, there we go. Okay, if I put 2 in, I get 2 squared is 4, negative 2, 2 squared is 4, make it negative, plus 4 is 0, so 2 is at 0. You're not really sure what's going on yet, so I'm going to go ahead and do 3. 2 squared, or excuse me, 2 cubed is 8, negative 8 plus 4, negative 4. 1, 2, 3, 4. So I'm thinking that this is going to start to shoot downward. It's going to do something kind of like this. And I'm going to make it shoot down, but I'm not going to cross when x is 4 because I don't have any answers there. Okay, I don't have a value. All right, let's see what happens at negative 1. If I put negative 1 in, I get 2 to the negative first, which is 1/2. Make it negative 1/2 plus 4, 3 1/2. So 3 1/2 is going to be right about there. When I put -2 in, I'm going to get 2 to the negative second, which is 1/4, make the negative, plus 4, which would be 3 3/4. 3 3/4. And look at that, it sure looks like it's approaching the line y equals 4, just like I thought it should. Okay, something like that. And so yes, my asymptote is going to be this line, y equals 4. The negative on the base, the -2, causes my exponential graph, my curve, to flip below, to reflect below the asymptote, right? So we had a negative on the exponent, it reflected over the y-axis. If I have a negative on the base, it flips or reflects below the asymptote. All right, now let's get to this new problem. For honors, it's not new, but for the level 2 kids, it is. And we're going to need this formula here. Let me give you a formula. It's going to be A equals P times the quantity of 1 plus or minus R to the power T. I'm going to tell you what everything is, and then we're going to go ahead and see how to use it. Okay, A is the amount after T years. Okay, T years. P is the principal, not the Mrs. Armentrout, not that kind of principal, the principal. And what it means a starting value. It could be the money you're investing in an account, it could be the population of a town. Okay, these are exponential growth and decay problems, by the way, if you were wondering. Okay, I'll tell you why the one's there in a minute. R is the percentage divided by 100. Okay, R stands for rate, but you have to be careful. If you were in second period on Friday, you heard me ask Cameron, and he knew to not use 3 for 3%. You have to divide by 100. So R is the percentage divided by 100. And this is very important. T is the time in years. Very important. Okay. Now, before I actually go and do a problem and show you how to use it, I want to talk about why there's a 1 in the middle here. So I'm going to go over here and A equals P times the quantity of 1 plus or minus R to the power of T. All right. If we put $100 in the bank, right, and they were going to pay us 10% interest, well, after the first year, we would have an extra $10, right? 10% of 100 is 10, and so we'd have $110. Now, if we wanted to keep that money in the second bank, we'd have $110 invested at 10% interest. Our interest wouldn't be $10, it would actually be $11. And then our money would end up being the 11 plus the 110, which would be $121, right? Do you notice what I'm doing? I'm calculating how much I get from the interest, then I'm adding it to what I started with, and that's where the 110 comes from. And then on the next one, I had to take the new value, calculate the interest, and then add it to get the new amount of the investment. And if I want to do this for 10 years, it gets really tedious because I have to do some long lines. This one here takes care of that. It takes care of me having to do it 10 different times and add them all together. Okay? I'll be able to do it all in one equation. Oh, by the way, some of you are wondering, why is there a plus or minus? Well, plus is for increasing growth, and negative is for decreasing growth. Okay? So if you're losing money on an investment, like when you buy a new car, it loses 30% of its value the instant you drive it off the lot. Or 20%, I forget the actual percentage. But anyway, so that's what the plus or minus is for. All right, let me get a little beverage to wet my whistle here. And let's go ahead and look at a couple of problems, okay? Uh-oh, my music's getting ready to restart. I better take it back to the beginning because I'm not quite done. All right. So let's go back to this problem here. Where did it go? All right, it says $8,000 is invested in the bank. Well, $8,000, that's P. That's the amount that we start with. That's P. In the bank for 4 years. That's T because it's in years. If it wasn't in years, if they told me a certain number of months, I'd have to convert it to years, okay? At 3.5% interest. Well, if I divide this by 100, then I'll have R. What will be the value of the investment at the end of 4 years? Now, since it's 3.5% interest, it's a growing account. So we know that it's going to be plus R, not just plain old R, won't be minus R. Let's stick it into our equation. All right, I don't know A, that's the amount after T years. The principal, P, is $8,000. And we're going to have a 1. We're growing. Now I have to do 3.5 divided by 100. And that goes 1, 2. It ends up being 0.035. You don't know how to do that. Make sure you ask about it on Monday. 0.035 and the time is 4 years. Now, if you like, you can simplify this. 8,000 is going to equal 1.035 raised to the fourth, and you can go to your calculator at this point. And I'm going to keep talking to you because I don't know how to pause the video, but I have to go get a calculator. Sorry, I can't do these powers in my head. But anyway, while I'm doing it, I can tell you how proud I was of your performance on the OAA. Don't worry about the one question that seemed to trouble some of you. I know you can't tell me in detail what it was. You did your best on everything else. It'll all be fine. So, that's all anybody can ever expect of you is your best. All right, so I've got my calculator. I'm typing 8,000 and a quantity, 1.035, and I'm raising it to the fourth power. And when I do that, I get this big, long, ugly decimal. I don't have a graphing calculator on here at the moment. $9,180.184005. Now, it would be ridiculous for me to report this as an answer because I'm talking about the value of a bank account. So therefore, I'm going to round it to the hundredths place. I'm going to look at this 8. I might have 18 cents. I might have 19 cents. I'm going to look behind the 8. It's a 4. 0 to 4. 4 or less. I'll give it a rest. So my value of the account after 4 years is $9,180.18. And there you go. Pretty simple. Just a plug and chug problem, really. Let's try it on another one. This one, the population of a town is 50,000 people. You know what? That sure sounds like P. Okay. Here's my P, 50,000 people. I'm starting. The town is losing population, a rate of 2.1%. So I'm going to take this, divide by 100, but it's also going to be a negative. All right. So R is actually going to end up being, negative 0.021. There's R. I took the 2.1%, I divided by 100 to get it as a decimal, and then there's my R. Now the problem says, what will be the approximate population of town in 6 months? It also says in 7 years and 5 years ago. Well, in 6 months not in years. 6 months is what fraction of a year? Well, it's half a year, right? 6 divided by 12. Okay, so I could use 0.5 or I could use 1/2. Now I'm going to set up my equation. A equals P times the quantity. 1 minus 0.021 and put it to the 0.5 power or 1/2 power. Okay, I don't know if you realize this. Taking something to half power is like taking the square root. Oops, I should have put the P in there. The P was what, 50,000? 1 minus 0.021 to the 1/2 power. All right, so I'm going to go ahead. Some of you might be thinking you should distribute here. Remember your order of operations. We have to do exponents before multiplying. If you want to simplify, there's one step you can do, and that would be this. Let me see here. That would be 0.979, I think, right? 1 minus 0.021. Yeah, there we go. To the half power. Now, if you don't want to simplify that, you don't have to. It's a good mental exercise, but you don't have to do it. You could just type this into the calculator, this whole expression right there. So here I go, 50,000 times the quantity of 0.979, and I'll raise that to the half power. And I come up with, in 6 months, the population will be 49,472.2 people. So I'm going to say about approximately equal to that many people. Okay. Probably be a little more, like 473, but I've got to make context and I've got to give a decimal of a person. To do it in 7 years, part B, it's the same exact thing, except I'm going to do 50,000. I think that's only 5,000. 50,000. And it's still going to be the 0.979. And then 7 for the exponent, because that's in years. So that'll get me this answer. And I can do the same problem here and change it to a 7. And when I do that, I get 43,097. And again, it's approximately that many people. Okay, now does that make sense? In 6 months, we're still pretty close to the population. But 7 years later, we're down almost 7,000 people. Yeah, that should make a lot of sense. All right, C is really cool because a student showed me how to do this. I used to do it another way. I used to pretend that P was A if I was going backwards in time. And I would do it like this. I would put the 50,000 in A spot, and then I would use my math, 0.979, nothing else has changed, and solve for P. So I divide by 0.979 to the 5th, and divide by 0.979 to the 5th. But several years ago, the student's probably about 21 or 22 by now, the student said, hey, Mr. Lawrence, I think about it this way. I think about 5 years ago as being a negative time. Negative time. And he said, I go 50,000 times 0.979, and I raise it to the negative 5th power. And I thought about it, and I said, wow, that's ingenious. Because what does a negative exponent mean? It means to use the reciprocal, right? If I move this denominator over here in green, if I move it to the numerator, 50,000, right? If I want to move that quantity up, I could go 0.979. I have to change the sign on the exponent. And look at that. That expression matches this one perfectly. Anyway, so let's get the answer for that. I like to use the negative there. All right, so we're going to go 50,000 times the quantity of 0.979, and we're going to raise it to the negative 5th power, going backwards in time, and notice our population went up, which makes perfect sense, 55,597, and again, it's approximately. All right, that's going to be the video for tonight. The bell is rung. It's Friday. I got more work to do. Not time to go home. I'll see some of you at the dance tonight. Mr. Lawrence signing off, saying, have a good night, everybody. Or should I say, goodbye? No, that sounds like I fell off a cliff. Never mind.